Hello, welcome to my tech fun. In this video I would like to present you the SK1 CD printer, which is sent to me by the TwoTrees in exchange for a review. This is their newest fast CoreXY printer based on Klipper. The build volume is 256 mm cubic, what a coincidence, 4.3-inch touchscreen, and according to specifications the maximum speed is 700 mm per second and 20,000 mm per square second is the acceleration. Now it used the linear rails on all three axes, and this is new because usually those CoreXY printers I tested so far usually use those linear rods or something like that. Now it has a Z-tilt leveling plus 36 points bed mesh. And this is again something new. I saw these solutions maybe on a Voron printer, for example. This means that probably it is able to independently move those lead screws of the Z-axis to make that bed level near equal, and then it can do the leveling, auto leveling, and if there is any inaccuracy, then it will be compensated during the printing along the Z-axis. The maximum nozzle temperature is 300 degrees Celsius. I couldn't find information about the bed temperature. I will test it later. And this is not enclosed 3D printer. This means by default you cannot easily print ABS, polycarbonate, and nylon or similar. So far we are stuck with PLA, PETG, maybe TPU and something similar. Let's see what's in the box. And this was content of the box which was inside the printer. We have here 250 gram sample filament on the spool, which is big plus. User manual, this is that 4.3-inch touchscreen for the Klipper. We have some bolts and tools for the assembling, brass brush for cleaning the nozzle. This is the spare nozzle. This one looks like it's from hardened steel. Now I'm worried about its size. I'm curious if it is really able to melt the filament on 700 mm per second. Maybe I will measure the maximum flow rate later. And very nice that we have these tweezers, but TwoTrees, the flat one is better. This is more dangerous, and flat is better for the cleaning the nozzle. Well, let's take a closer look of the printer itself. Here you can see the linear rails on X and Y axis. This is a 6mm GT2 timing belt. Those are two stepper motors for CoreXY mechanism. And it used the drag chain for delivering the power cable. And this is the Teflon for the filament. This is a texture PI sheet, but it looks like it is only one-sided. Now we have some bolts for the aligning, but unfortunately quite unique solutions, so you cannot easily replace them if you want to use those aligning pins. And yes, I can independently rotate these lead screws. This means probably even the motor can be rotated independently. That's for that Z-tilt leveling. Now I measured the bed surface. It is exactly 256 mm in X and Y direction too. So this means we have zero margin, but a little bit confusing in user manual. It says the print size is 254 mm cubic. On the website it says 256, and actually everybody knows that most of the printer use the 256 mm. Well, without that margin, it must be very accurate with the positioning of the printing. We have to keep this in mind if we want to print the whole surface. There is no thermal insulation from the bottom of the heat plate, but since this is only for PLA PETG, probably it's not even needed. I can see they use the backlash nut on Z-axis lead screws, but I think they should be assembled upside down, because as they are now, they are working against the gravity, but actually this backlash nut should help the gravity, so they should always press down this bed. But now actually the springs must be much stronger than the gravity, and I think the upside down assembling would be much better here. Probably it will do the job as it is now, but in this case this spring must be much stronger than the gravity which pulls down this part of the bed. Maybe they didn't have enough space. If it is on upper part, then this must be higher, and maybe it's in the way of the head. I will see when it starts with the moving. This is the right side of the printer. Here we have the plug for the LAN cable, USB ports, connection for the screen, antenna, and this is a plug for the power cable and the main switch. This is the left side. Here we have only this switch to check if the voltage is set correctly for our country. In my case, yes, 230 volts. I'm in Europe, so it is okay. On the back side, no additional plugs, only some ventilation hose here, and there is some fan. Let's see what's inside, and here I have to remove these 8 bolts. This is the power supply unit. The output is 24 volts and 350 watts. And then we have 3 independent Z-axis stepper motors. Now I can see quite a lot of fans. So here we have the fan inside the power supply unit. Then we have this fan which sucks the air inside this area. And then 2 additional fans which blows the air over this heat sink on stepper motor drivers. I hope it's not too loud, but I will measure this later. This is the main board on all high current wires. I can see some terminals, and these are stepper motor drivers X, Y, Z1, 2 and 3. At this moment I'm not really sure where is the extruder stepper motor driver, but probably it's somewhere here. Everything looks okay here. Let's assemble it. The user manual is not so detailed as I thought so, because it's on 3 languages: Chinese, French and English. But assembling is very simple, so let's do it. In the first step it says remove Z-axis fixation, but in my case it wasn't fixed, the Z-axis. The X and Y-axis, yes, so I have to remove this, looks like 3D printed parts. If you want, you can reuse these boards, inserting back into the linear rails. And same on the other side. The spool holder. Well, if somebody will claim that this is a copy of any other printer, take a look. Spool holder on the side and not on the back side, so this is unique. Actually, this was the hardest part of the assembling, but with some pliers it can be done. So the screen is not removable. Well, in user manual it's not mentioned, but if you want better Wi-Fi connection, then you should install this antenna. The power cable. This is quite early product, and TwoTrees asked me immediately to update the firmware, but first I want to turn it on and then to see, I don't know, moving of the axis and similar. Nice LED lights. I have to switch the language somehow. The screen is really nice, responsive touch screen, like on a smartphone, not the one you have to press or something like that. I really like the screen. It's a pity that I don't have this kind of screen on my kiddie or flashforge printers. But what I don't like, that even now I can see quite a lot of fans which are working, and this means that we don't have that quiet standby position. Pity. There is a very detailed animation how can we update the firmware on their download page. It's grouped in 3 steps. In first one we have to flash the firmware on the main board, and then write the image on eMMC board, and for this we need some tools which are included in the kit. And in third step, flashing the firmware on the screen separately. And after this the printer is ready for the self-configuration and then for printing. Separately I got a spool of the PLA, unfortunately in white color, so it is not the best for the camera, but for the beginning of the testing I will use this filament. I already set the network. Let's go through the calibration process. The first is the Z-tilt calibration. It is preheating now. It's touching the bed in 3 points, and after this it will try to do some leveling to make it absolutely horizontal as much as possible. Next step is setting the Z offset. Again, it's preheating. Okay, perfect friction, and I know that many beginner users will hate this part. Okay. The next is the auto leveling. It will create some kind of mesh and it will compensate during the printing if there is any inaccuracy along the Z-axis. This step is finished. 2Z max is 0.05 and the minimum is minus 0.47. Acceptable maybe. And the last step in the calibration is the input shaping. It's measuring some resonancy because it has a built-in accelerometer, and these vibrations and sounds are normal. It will do along the X and later along the Y axis. Interesting, it didn't finish the input shaping, or what is that emergency stop, so I'm a little bit confused. I'm not quite sure, but the screen got blank, and when I touch it to wake it up, that emergency stop appeared. Maybe I touched it exactly here, pressing this button, so I have to be careful with this next time I touch it here. And this time it was finished correctly, so be careful where are you touching the screen when it's in standby mode. Let's see what we have in the folders. Local memory is empty. There is no USB currently, and there is no printing history, so I have to prepare the slicer and prepare my own G-code. I really appreciate that they prepared profiles for Ultimaker Cura and also for the Prusa slicer, and ending of the profile is very easy, so I just have to add the file to this Ultimaker Cura and everything is prepared by default. And these 6 dice and a calibration cube will be my first printing. Inserting the filament. No preview image, unfortunately. This is very dangerous, touching the touchscreen when it's in standby mode. The start looks good, and now it's speeded up with the second layer. Let's see the LED lights. Much better. According to Slicer, the printing time will be approximately 7 minutes, which is realistic, and actually it looks like it will be 7 minutes, but these data on the screen are nonsense. It says it's printing 38 minutes and now it's switched. 18 minutes remaining, so 6% the printing, but actually you can see it's 70. So this data doesn't make any sense here. It was finished a few seconds ago. Immediately let's check the bed adhesion. Okay, it's good until it's hot. I will wait until it cools down. The bed cooled down. Perfect. Well, let's analyze it. This is the first layer. There is some dirt from the previous filament, which was black. These are side surfaces, and well, there is no ghosting, but this was printed quite slow. And this is the top surface, which also looks great. I sliced the Benchy with 0.28mm layer height, but even then this will be a 22-minute Benchy. The default speeds are quite low, 200mm per second. I uploaded the job over the fluid. The start was correct. Here you can see some real-time footages. Bed adhesion check. It's great. And when the bed cools down, perfect. Now the quality of this bench is not absolutely perfect. It's a little bit hard to see on white color. Let's analyze it. So great first layer, but I can see it could use a little bit more part cooling here on this surface. Don't forget this printer don't have the side aux fan, and I can see some inconsistency here, but this also may be a result of the weaker part cooling. And then I can see some inconsistency on this side panel of the cabin here. I'm not sure is it visible on camera too. Few strings, but that's nothing special. Well, otherwise the quality of this Benchy is acceptable. Great bridging here, but don't forget this is 25-minute Benchy. This is a bed level test, and I think this auto leveling could be done with a little bit lower temperature of the nozzle, because I always have a lot of oozing from the nozzle during this test. And it's always risky to go there with your hands, because this is very fast printer. If it starts with the moving, then it can catch your hand. I removed the purge line so it will not be in the way. This is a bed level test. The maximum dimensions are 250 by 250 millimeters. Well, first of all, I can see that it is not completely in the center, so here it is very close to the edge. If I would use the complete 256 millimeters, in that case this would be off the bed. Also, I can see some inconsistency in the layer thickness, so here I can see it almost scratched the surface, and there is some inconsistency here and here on one line. This part and the middle part is okay, and maybe here I can see some smaller error, but actually if this would be the first layer, the second one would completely cover it, and actually we couldn't see anything of this. Don't forget these tests may include a human error. Maybe I should go lower with that friction during the Z offset settings. And now I want to measure the maximal flow rate, and I prepared this G-code using the tool which is developed by Stefan from CNC Kitchen. And I'm doing this on two temperatures, the first column 220 and then on 240 degrees Celsius. And then I measured each element on the scale, and then I can analyze it in the graph. And if we analyze the results in this graph and take a 5% reduction as a limit, in that case we can see on 220 degrees Celsius the maximal flow rate was 11.5 cubic millimeters per second, and on 240 17, which are quite low values, but something what I predicted when I saw the nozzle size. Maybe they could improve this using some kind of CHT-like nozzle or something like that. And using this information, I prepared another Benchy printing, this time with 0.2 mm layer height, and I also limited the maximal flow rate here. Well, the improvement is quite obvious, so now this overhang came out great because the part cooling is enough with 0.2 mm layer height, and even the sidewall is much more constant now because I limit the flow rate to 12 cubic millimeters per second, and even the stringing is reduced too. Let's see if the unload is done correctly with this newer firmware unload. This means before the retraction it should extrude a little bit and then pull back the filament. It's heating up now. Great, it is extruding first and probably now it will retract the filament. Something wrong here. So simple thing, but on this part still needs some improvement. So first it must extrude it just a little bit and immediately after that pull out. But I'm not sure, it starts to extrude and then it stops, wait maybe half minutes and only then it retracts the filament. This is not how it should be done. See this end of the filament? So this is not healthy unloading of the filament. From this I can see that this is not done correctly. Anyway, I will insert new filament. This is Polytera PLA. I want to print something in the vase mode and then some bigger printing, and that's it. Anyway, loading of the filament works correctly, only it would be better maybe to extrude a little bit less filament, or maybe I should choose how much filament I want to extrude. I noticed we are quite limited with the settings possibilities over the screen, so I can change the nozzle or the bed temperature. I can change the fan speed. We don't have the aux or the case fan. But I cannot change the printing speed or the flow rate, so I can do it only over the web interface, over the fluid, but it would be good to have more setting possibilities over the screen too. In the meantime, it started with the printing in that spiral path, and it looks okay. There is no break or something like that, but actually Klipper don't have the problem with this kind of printing, and everything looks okay here. Next will be a longer printing. This is the hour from my 3D scanning video, and I tried to keep the flow rate around 12 cubic millimeters per second. The fastest is the infill. Now I tried to upload over the network, but it would require 25 minutes, so I just uploaded over the USB drive. This is printing of the infill, the fastest in this case. I also measured the noise, approximately 62 decibels from half meter distance, which is average for CoreXY printer, which is opened. Here the printing is at 50%. The bed cooled down. Well, the quality is okay. This is the first layer, and thanks to this flow rate limitation, the printing time was a little bit more than 3 hours instead of 2.5. I also checked the extrusion. I mark here the line on 60 millimeters, and I extrude exactly 50 millimeters of filament. This is speed up a little bit. And instead of 50, it extruded 46.5 millimeters. So I calculated, I changed the rotation distance. I have to reduce it to have more filament extruded. And then I extruded another 50 millimeters, and this time it was correct. Almost. And at the conclusions, and I'll start with things which I like. And this is really robust frame with linear rails on all three axes. For this price, the hardware is really great. I really like the CoreXY mechanism, the textured PI sheet, the really responsive, nice touchscreen, fully open Klipper. I really like this Z tilt function, but here we are slowly moving to the parts which I didn't like. In theory, it should level the bed horizontally as much as possible, and then the auto leveling should compensate any inaccuracy along the Z-axis, like warping of the bed or something like that. But I can see that we have a half millimeter difference, but I cannot see so big warping on this plate. So this means that Z-tilt function, maybe it should do a few more steps, I'm not sure, but this difference is a little bit too big, especially if we have this Z-tilt function. Now be careful with the touchscreen. If it got blanks, if you touch it to wake it up, you may press some buttons, so try to remember where to touch it. My solution was actually I disabled that power saving function, so it is always on when it's operating. I think that unload function should be a little bit more improved. I mean, these are just macros in the Klipper, but actually it should extrude just a little bit filament, and immediately after this it should retract the filament, and then we can pull it out. Not waiting, I don't know, half minutes before these two operations. And my biggest issue with this printer is actually the maximum flow rate. With this small nozzle, something I predicted at the beginning of the video actually, that the flow rate is quite low. So pay attention to this, and you should measure this for your filament and printer, and enter this limitation into Slicer. One of the solutions may be just inserting those CHT-like nozzles. With this, I believe that we can get much bigger flow rates. The part cooling is enough if we are using 0.2 mm layer height. With bigger, well, it became critical then. But actually the real solution to this would be to enter some bigger hot end and maybe something like volcano nozzle or something similar. In standby position, it should be completely silent, so they should turn off all those fans which are working inside. I still think the backlash nut should be on opposite side, but until the springs are stronger than the gravity and the vibration, until that it will work fine. But as a mechanical engineer, this is partly professional information, I would suggest them to mount them on the opposite side. This was my experience with the SK1, so the base is really good, the hardware. On software side, it needs just a little bit more improvements, but if you want to print PLA, PETG, PPU, in that case, this may be a good printer. Thank you for watching and happy printing!